Today, we will be solving two more examples, okay, related to scheduling, the last one in scheduling. And then we will be moving to the next unit, that is process synchronization. Okay, so say for example, let us take this example one. Okay, so we have process ID, arrival time, then we have burst time. This is for CPU burst time. This is IO burst time. Again, we have CPU burst time. Okay. P1, P2, P3. P1, P2, P3, P4. And arrival time is 0, 0, 3, 6. 3, 2, 2, 1, 3, 1, 3, 1, 2, and 5, 4. So now, based on this, if we are following, we need to calculate the same thing. Okay, that is let us say what will be the average waiting time using SR here. Okay, so now this we need to solve. Okay, so let us take this one. This will be ready. Okay, this will be the run state, and this will be the wait state. Okay, now see. So at time t, at time 0, what happens? We have two processes, P1 and we have P1 comma P2. Okay, now so we have two processes P1 comma P2. Okay, so what will be the Gantt chart now? So the Gantt chart at time 0 will start with process P2. Okay. And what is the burst time of P2? It is 1. So it will go till 1. Right? Now see, at time 1, what happens? At time 1, what happens?
P2 to wait.
So once P2 start executing, P2 is in run state from 0 to 1. This I am talking about 0 to 1. P2 is in run state. Okay. At time 1, what happens is P2 comes to wait state. Why P2 is coming to wait state? Because it has some IO bound operation, so it will be moving to the wait state. Now what will happen to CPU? Now CPU will see short-term scheduler will see what is there in ready queue. In ready queue, there is only one process. What is that process? P1. So P1 will be moved to run state. Okay. So at time 1, P1 moves to one state. Now P1 will start executing. Till what time P1 will start? P1 will work up till 3. What happens at time 3? What happens at time 3? Okay. At time 3, we have a new process, P3. Yes or no? P3. What is the burst time of P3? CPU burst time 3. And what is the burst time of P1 at time 3? 2. So P1 will be running till what?
4, sir.
Till 4. Now, what happens at time 4?
P3 will execute.
Now, at time 4, now how much? 1 to time 4. What we have? Any process has arrived? No. The ready queue will have two process, P2 and
P3.
And P1 will go to
Wait state.
wait state. So at time 4, this is the scenario. At time 4, this is the scenario. So what will happen at time 4? So in short-term scheduler has two processes in ready queue, P2 and P3. What is the burst time of P3? 3. And what is the burst time of P2? 1. What will happen? At time 4, P2 will work till time 5. And P2, so at time 4 to 5, P2 is in run state. Yes or no?
Yes, sir.
This is the scenario this is the scenario. At present, this figure is talking about from time 4 to 5. This is the scenario. Okay. Now, what happens at time 5? What happens at time 5? So, from 4 to 5. At time 5, P2 is finished. P2 will go. Yes or no? Will be terminated. Is anything left for P2? P2 is, sorry. So what we will do now? P2 has completely terminated. Okay. This will indicate which process is terminated. Yes or no? P2 has been terminated. Now, from at time 5, what happens? For what is there in ready queue?
So P3.
P1 will also complete.
No.
Yes. At time 5 we will have P3 and P1. Okay. So
Sir, on P3 na sir. It takes 2 seconds for IO.
Sir, IO time is 2.
Sorry. P1 will be in this state. Okay. So P1 will be in wait state. P3 will be in it. So at time 5, what happens? P3 will start executing. Okay. So at time 5, P3 will start executing till time 6. P3. What will happen at time 6? At time 6,
P4 and P1 will come into ready queue, sir.
P1 will come in ready queue.
P4 also, sir.
So at time 6, what we will have P1, comma P4. So at time 6, so what will happen at time 6? Now see, what is the burst time of P1? 2.
2.
What is the burst time of P4? 5.
5.
What is the burst time of P3?
Sir, 2, sir.
So P3 will go up to 8. Okay. So at time 8, what will have? At time 8, we'll have P3 in wait state. Yes or no? P3 will be in wait state. What will happen? So this is at time 8. At time 8, we have this figure. At time 8, okay, we have this figure. Yes. So what will happen? Who will be executed first at time 8? So at time 8, what we have P1 has burst time of 2 and P4 has
P4
burst
has
time of
5.
5. So P1 will execute till time 10. Okay. P1 will execute till time 10. No, let us not go like that. Okay. So P1 will execute till 9. P1. So this is for time 8 to 9. What will happen? P1 is in run state. What will happen at time 9? At time unit 9, what will happen? P3. We will have P4, comma P3. And P3 is out of ready state. Yes or no? So what is the burst time of P3? P3 burst time is 2.
2.
Yes or no?
Yes, sir.
P4 burst time is 5. What is the burst time of P1?
1, sir.
1. So what will happen? P1 will execute till
10.
time 10. Sorry. So it will be P1. At time 10, what happens? At time 10, what happens? P1 goes out. Okay. So at time 10, what we have is P1 is also out.
Yes, sir.
Yes or no? So this is terminated. This is also terminated. So this is the position what we have at time 10. Okay, at time 10. Now what we have P3,
P4 ready.
and P4. Yes or no?
Yes, sir.
This is the situation. P3 is having burst time 2, P4 is having burst time
5.
5. So what will happen?
P3 will come.
P3 will go to run state. So from 10, okay, from 10 to 12. Yes?
Yes, sir.
10 to 12, P3 will work at time 12. Time 12. What we have? We have this scenario, and what we do over here is this is also terminated. Yes. Now at time 5, there is only one process remaining. So what will happen? P4 will go to run state. P4 will execute till 17. I think 5, 17. P4 will execute. What will happen at time 17? Time 17, P4 will go to wait state. Why P4 will go to wait state? It has to execute IO bursts. So from 17 to 21, from 17 to 21, what we have? We have this
CPU.
as an ideal state. Yes or no? Now at time 21, at time 21, what happens? We have, you can see, P4 is again is in the ready queue. Yes or no?
Yes, sir.
And it will move to at time 21. What happens? P4 again from ready queue short term scheduler has no other job. It will start executing P4. So P4 will work till
26.
26. Is it clear? Is this whole figure clear to all of you?
Yes, sir.
So this is how we will be solving, and this is my ideal state.
Excuse me.
Yes.
Sir, at time is equal to 6. P3 and P3 was in run state, and sir, P4 and P1 were in ready state, sir. At time is equal to 6. So there was a tie of the burst time between P1 and P3, sir. So, sir, will P1 be executed? Or sir, P3?
No. No. When all the process is available, STRF becomes non-primitive SJF. Remember, what is difference between STRF and SJF? When STRF will become SJF? When one by one process will come, then it will go for primitive. When all processes available, it will go for non-primitive SJF. Remember?
Yes.
So that is why at time 6, P3 is continued.
Okay.
Now, if P4 has not arrived, okay, at time 6, we are talking about this point, time 6. No tie condition, P3 was executing. In that case, we will be going for the same logic. We can print P1 and we can go for P3 and we will go for P1 if we have having tie. It depends what coding we are following. See, I can print, I can not print also. But if I go for simple rule logic, okay, that if there is a tie, lower process will be lower process with lower ID will be executed. I will go for preemption, or I can, if I see both are having the same burst time, if I execute both of them, any one of them, will it affect my waiting time turn or not, average waiting time? If it is not activating, if it is not affecting, I may go for preemption, I may not go for preemption. But simple logic is, if we have a tie, we'll go for a lower process ID code. So we have process arrival time, exit time, and VAT wait time. P1, P2, P3. P1, P2, P3, P4. 0, 0, 3, 6. P1 exit time is 10. P2 exit time is 5. P3 exit time is 12. P4 exit time is 26. So we have 10, 5, 9, 20. Okay. Now what will be the waiting time? 5, 5, 3, 4, 10. Is it clear? Waiting time?
Yes.
IO bus time is not, see, your waiting time, on what we are calculating the waiting time. Go back to the previous class where I have taught you the times, various process time, and see what is the definition given for waiting time. Amount of time spent by a process in the ready queue for getting the CPU. So this is completely related to CPU.
Ready.
Very good. जो भी बोल ready queue. This is completely related to ready queue. This is not related to wait queue. Job queue, ready queue, and one more queue was there. What was that? Tell me. Job queue, ready queue,
Waiting.
Waiting queue.
waiting queue. ठीक है ना? So this waiting time corresponds to ready queue, not waiting queue. ठीक है? So job queue is for your long term scheduler, ready queue is for your short term scheduler, and your waiting queue is for which scheduler?
Medium term scheduler.
Medium term scheduler.
Medium time.
So waiting time means the time taken by the CPU to execute that process. Okay, just a minute. Okay, so okay. So waiting time is nothing but it is the amount of time spent by the process to get to the CPU. Okay. So we will be only considering the CPU burst time, not the IO time. So it is related to ready queue, not when I am talking about this one, IO. Okay, this is related to which queue? This is my
Waiting.
waiting queue. So I will be only considering this one, CPU burst time, because in these two time I will be in the ready queue. So that is why we are considering. We will be only considering the CPU burst. So So is this column clear to all of you? So 10 is total around time. Total burst time of P1 is 5, 3 plus 2, P2 is 2, and P3 is also 5, and P4 is 10. So 10 minus 5, 5, 5 minus 2 is 3, 9 minus 5 is 4, and 20 minus 10 is 10. So total average waiting time 22 by 4. Is it clear now? Okay. So now we'll do one more question and we'll wrap up. Scheduling will be over. Let us give you one more question. Different. Now, question number 2. Question number 2. Okay. So we have 4 set of process. Arrival time, priority 2, 3, 1. 1, 2, 3. 0, 2, 3. 1, 5, 3, 3, 3, 1, 2, 3, 1. Burst. CPU, excuse me, IO and CPU. So, following primitive priority scheduling. Calculate average period. So, lower value represents the higher priority. Solve this one. Will be in wait state. What happens to CPU at time 1? CPU is idle till time 2. So at time 2, what happens? We have the P2 is in only, so short-term scheduler has only one process in its what? Ready queue. So it will start executing P2. So P2 goes to run state till time 3. What happens at time 3? At time 3, we have P3 in it. So what will happen? P3 will go to run state and P2 will move to ready state. Okay, like this it will go. P3 will be moving to run state till time 4. What happens at time 4? Time 4, 1, 2, at time 4. Is there any other process apart from P2 and P3? No. P3 will execute till 4 and 5. Okay. What happens at time 5? P3 first time is 2. So P3 is now at time 5. At time 5, what happens at time 5? And first time is at time 5, what happens? P1 and P3 are in wait state and P2 is in ready state. So P2 starts executing, right? Starts executing. P2 will start executing till 6. At time 6, what happens at time 6? At time, yes, P1 is moving to ready state. Now, see the priority. Yes,
P1, sir.
P1 and P2, who has the highest priority?
P1.
P1. Again, we have a change over here. So P1, P2. Yes or no? P1 will execute till 7. What happens at time 7? So wait state P3, 4, 5. P3 is in again wait state. At time 7, what will be the positioning of P3 in which state? Wait state, P2 in ready state, and P1. So the competition is only between P1 and P2. So who will win? P1 will win and it will start from 7 to 8. P1. Okay, at 8, what happens at time 8?
P3 goes to ready state.
At time 8, P3 goes to ready state. And P1, what happens to P1?
P1 remains in run state, sir, because of priority.
P3 is higher priority.
That is why we have three process P1, P2, P3. What is the highest priority? P3 has the highest priority at time 8. What will execute? P3 will execute.
P3.
So there is again change over here. So over here we will have P1, P2, and over here we will have P3. Okay. So P3 will execute till what
9.
time?
9.
9. 9. So what happens to P3 now?
Terminate.
Yes. Very good. P3 will be out. Okay. So we are now having one less process. At time 9, we do not have P3. Okay. So P1 and P2, which will execute?
P1.
P1. P1 will execute till what time? At time 10. P1. 6 to 8 already it has executed. It will execute. So how many
Sir,
time was
10
there?
only, sir.
At time 10.
Sir,
What
one.
happens at time 10? At time 10, we have P1 moves to which state? P1 is also terminated.
Terminate.
So we have only one process left with us. Yes or no? What will happen at time 10?
P2 will execute run state, sir.
How many P2? 1, 1, 2. What is the burst time of P2? 3. P2 will execute till 11.
11.
And at 11, time 11, P2. So P2 will move to state. Okay. Now, wait state. What is the burst time of P2? In IO, we have 3. So 11 to 14.
14.
This is our
Idle state.
ideal state. At 14, P2 is in ready state and we do not have any other process. So P2 will be moved to run state and we will execute till what is the time? P2 ka 1.
One.
It is
One.
P2. So this is how it happens. Now, is it clear now? So we have two ideal time slot over here, 1 to 2 and 11 to 14, right? This is the two ideal slot in our Gantt chart. So this is my Gantt chart. Okay. So, my whole time is 0 to 3. 0 to 3. Exit time. P1 exit time is 10. P2 exit time is 15. P3 exit time is 9. Is it correct?
Yes, sir.
We have 10, 13 and 6. Waiting time. This will be
9, 3.
9. Your average 80. Average time will be Is it clear? Hmm. So in many any competitive exam, you will get question like this also, where they have. So till the last class, what we have discussed, we have only discussed CPU bound process, but we may get a process which will be CPU as well as IO bound process. In that scenario, how our Gantt chart will be formed. This is how our Gantt chart will be. So for your better understanding, I have drawn this states so that it is easily understandable to you. So you can try one more question at home. Now, consider the set of four processes. P1, P2, P3, P4 process, arrival time, a CPU scheduling policy is FCFS. Calculate the average waiting time and average period. So this is your try at home. And question number 1A, B. If CPU scheduling policy is round robin. Okay, round robin. With PQ equal to 2, calculate the average waiting time. Copied? Yes?
I was just asking you to scroll up, but now you already did it. So,
Okay. Done? So do this in a form of a queue. Your ready queue will be always a queue. So remember, in FCFS, whichever process comes first in the ready queue will be executed. Okay, same amount, same concept will be there in round robin, but we have to maintain a slice. 2 2 second slice will be. So try this at home. Next class, I'll solve it.
excuse me, sir.
Yes.
Sir, in the first come first serve, if a process comes back to the CPU after input output process,
See for
does
example, now see for example at time t, at time 6. Okay, over here only. Answer question. At time 6. At time 6. What was my condition of ready queue? If this is my ready queue, P1 with 2, P4 with 5. Because at time 5, what was your question?
uh, so let's say there are three processes, P1, P2, and P3, and they arrived in that very order. And let's say P1 went out of the CPU for the input output process to the waiting queue. And when it comes back, will it still have the same priority as before, or will its
No,
priority
no,
be?
no. Why we are talking about priority over here if we are talking about FCFS?
Yes, I meant like, will it still be considered as the first
That is
process
what
to
I am
arrive?
telling. No, that is why what I am telling. Just take a case over here. Okay, at time 0, I'm discussing this question only. Time 0. Okay, what we have at time 0, my ready queue will have these two process, the 3, 2. Yes or no?
Yes, sir.
So this is my ready queue. So what will happen? My Gantt chart. P1 will execute till P3, right?
Yes, sir.
Okay. Now what will at time 2? What happens at time 2? At time 2, this was at time 0. Now at time 2, what happens? We have one more process. Say P3. We are keeping it to P3 only. Okay. For your understanding. We have this scenario at time 2. Yes or no?
P1 will have 1 second.
No. At time now. At time. So at time 2, P3 has arrived. Yes or no?
Yes, sir.
It goes into the ready queue and P1 is in the run Gantt chart. That is in the run state. What happens at time 3? Time 3, we have this in our ready queue. Yes or no?
Yes, sir.
Sorry, this will be 1. And what is P4? P1 goes to wait state. Okay. So what will execute now? So it is FCFS.
P2.
P2 will execute. Okay. P2 will execute till 5. What happens at time 5?
P4 arrives in the CPU and P4 is in the ready queue now, and P1
P1
comes
is
back
also
to the ready queue.
P1 is
Yes, sir.
also P4 P1 also comes to the ready queue. P4 also comes to the ready queue. Okay.
Yes, sir.
2 and 2 like this. Okay. So what will execute first now? So it is FCFS. Again, P3 will execute till time 6. What happens at time 6?
So why is P1 written before P4?
No,
Okay.
I'll change this. What is there in that? P4 again P1 2 2.
Okay,
Okay.
sir. Yes, sir.
Okay. 2 2. Now what will happen at time 6?
There's a tie here, so um, according to the diagram, it seems like P4 executes first, but okay.
First in, first out.
Yes, sir.
Is it clear?
Yes, sir. Thank you, sir.
Now you can solve it.
Yes, sir.
But keep this in mind in question number A and B. Okay. That is what I am telling. Keep this ready queue in mind and then solve your question. It will be easy then. Clear? Hope you have copied. So this completes our process scheduling. CPU scheduling is done. So we have covered all the algorithms and all the possible numericals. Okay.
So, sir, there were two problems to solve.
कौन सा प्रायोरिटी वाला?
So, HRRN and
हाँ. Problem which I had given.
yes.
When it was given,
in February.
Huh? Last class I had given on priority, I hope so.
Yes, sir. 2 on priority and 1 on HRRN.
Okay, just a minute. Let me. Okay, just a minute. Just a minute. I think that I had discussed, no? Okay. Let me search
Yes,
all
sir.
this. Let me get the questions one by one. I have not got the copy of that slides. Okay, I have got one for HRRN. Was this the question? Was this a question related to HRRN?
Sir, your screen stop, sir.
Just a minute. The screen is not shared, no?
Yes, sir.
Now?
Yes, sir.
So response ratio W plus V by P. So now at 0, at 1 we have P4. So P4 will execute till 2. What happened at time 2? Time 2. So time 2, this is non-primitive mode. This will go up to P4 was there, burst time is 3. What happens at time 3? Only P5 is available, right? So
Yeah, sir.
P5 will work till 10. What happens at time 10? We have how many process in ready queue?
Sir, P5 will work at time up to time 8. Time
What?
8, sir.
Sir, 8.
Burst time is 5.
Oh, sorry, yes. So at time 8, at time 8, so 8. What we have at time 8, we have how many process in ready queue? P2, P3,
P1.
and P1. Okay, so we need to calculate the response ratios. Yes or no? Response ratio of P2. P2. 8 minus 4 plus 6 by 6. Then P3. 8 minus rival times 6 plus 3 by 3. And P1. 8 minus 8 plus 4 by 4. So this is your 10 by 6. This will be your 5 by 3. Is it clear?
Yes.
Yes, sir.
Yes, sir.
P1 will execute. कब तक execute करेगा? 12. सर अभी change करो. At time 12 now. At time 12, what we have? At time 12 we have P2 and P3. P2 and P3. So response ratio of P2. 12 minus 4 plus 6 by 6. P3 12 minus 6 plus 3 by 3. So this is 8. 14 by 6. 2.33. This will be 9 by 3. Is it clear? P2
Yes.
P2 will execute till 18, then P1 will execute till 20. So this will be your Gantt chart.
Excuse me, sir. Yes, sir.
Yes, sir.
Yes,
Even
sir.
at the lowest
Yes,
ratio.
sir.
I have taken it.
Sir, highest ratio
Sorry.
in
Yes. time 8 P2 will work. Let us, yes. At time 8, we have P1, P2, P1, 8 minus 8 plus 4 by 4, 2, 3 minus 4, 6 by 6. Eight minus 6. So P2 will work over here because there is a tie. If there is a tie, we will break it by FCFS, and arrival time of P2 is before P3. So P2 will execute till 12, and at time 12, what we have at time 12, this goes off 12.
So it's 14 now. 12 now. 14.
Burst time is 6.
So P3 will work. What is P3? 17. Then P1 21. This will be your Gantt chart. This will be the final table. This you will get. Have you got this?
Yes, sir.
There are two questions from round robin. That was solved, no? Okay. Okay. Just a minute. Time. Priority 5, 6, 4. Burst time 4, 3, 1, 5, 2. This was the question.
Yes, sir.
Using non-primitive, no?
Yes, sir. Non.
So, and there were two parts, when higher priority is higher and higher priority is lower, right?
Yes, sir.
So, 0, P1 will execute till 4. At time 4, we have P2, P3, P4, P5. So, which has the highest priority?
P5, sir.
At 10, we have P2, P3, P4. P4 will execute till, sorry, this will be 2. Then P4
Six,
will
sir.
execute
Six.
till P4 will execute till 11. Then P3 will execute till 12 and P2 will execute till 15. So this is your process P1, P2, P3, P4. P1, P2, P3, P4, P5, arrival time, end time, PAT, wait time. 0, 1, 2, 3, 4. End time of P1 is 4, P2 is 15, P3 is 12, P4 is 11, P5 is 6. 4, 14, 10, 8, 2, 0, 11, 9, 3, 0. You have got this?
Yes, sir.
Yes.
Ab high equal to low. High equal to low. We have 0, P1. P1 will execute till 4. At 4, we have P2, P3, P4 and P5. So P2 will execute till 7. Then P3 will execute till 8. Then P4 will execute till 13 and P5 will execute till 15. Four, 7, 8, 13, 15. 4, 6, 6, 10, 11. Waiting time 0, 3, 5, 5, 9. ठीक है? This is for B. when high is low. Got this?
Yes, sir.
और एक था ना with we have one more.
Yes, sir. Yes, sir. Primitive parent.
Primitive था, हाँ primitive था. Okay. Just a minute. So process priority AP and BP.
सर ये स्क्रीन शेयर नहीं है.
हाँ पता है, क्वेश्चन लिख लेने दो. अरे एक तो क्वेश्चन यार मुश्किल से खोज रहा हूँ, खुद मुझे याद नहीं है. लिख लेने दो, मैं शेयर कर दूंगा. This was a question.
Yes, sir.
So 0 to 1 P1, then P2, 2, okay, at 2 P3 arrives, so P3 will be executing till
5.
5. At 5 we have process. What will happen at 5?
P4
We
and
have
P5 होंगे.
अरे P4 होगा P5 होगा और P2 भी होगा ना? नहीं,
ये सर P2 भी होगा सर।
P2 भी होगा। सो P5 P2 का तो एक ही ना यूज हुआ है 1 to 2 में।
Yes.
P2 का burst time is 6, so there are 5 burst time of P2 remaining. We have 5 burst time of P4 and P5. And what is the priority? Which has highest priority? P5?
P5.
Sir P5, yes.
P5 will go up to
10 sir.
10. At time 10, what we have? P6 PA. So we have
P4.
we have P5 is out. So we have P4, P6 and
P2 and P2.
अब कौन एग्जीक्यूट होगा? P4
Yes sir.
कब तक एग्जीक्यूट करेगा?
Till
15
15.
sir.
15.
Now at 15 P4 भी out हो गया. So what we have? P2, P6
P7.
and P7.
P7.
ठीक है ना? अब इसमें क्या होगा? P4 के बाद क्या एग्जीक्यूट करेगा बताओ? P2
P2 sir.
till 21.
20 sir.
20 sir, 20.
20.
Sorry
20
sir,
sir.
20. हाँ 20. 5 बचा हुआ है 20. ठीक है? 20 पे क्या हो गया? P2 भी हट गया. अब बचा P6 and P7. तो 20 पे क्या काम करेगा?
P7 execute.
P7.
P7 एग्जीक्यूट होगा 20 से लेके
27 तक.
7 तक. यस और नो? फिर
Yes, sir.
P6
Yes,
काम
sir.
करेगा 40 तक.
Yes sir 40 तक.
चलो बनाओ. प्रोसेस P1, P2, P3, P4, P5. Six, seven. Arrival time 0, 1, 2, 3, 4, 5, 6. एंड टाइम देखो P1 का एंड टाइम 1 था.
1.
P2 का एंड टाइम 20. P3 का एंड टाइम 5. P4 का एंड टाइम 15. P5 का एंड टाइम 10. P6 का एंड टाइम 40. P7 का एंड टाइम 27. ठीक है? इज इट क्लियर?
Yes, sir.
So 1, 19, 3, 12, 6, 35, 21. Waiting time.
Sir,
0.
12.
What?
12 is the
Sir, arrival time for P7 15, sir.
Okay. Oh,
You wrote 6.
2, 3, 4, 5. ये 15 होगा. ठीक है.
Yes, sir. 27, 21 minus.
This will be 12.
Yes, sir.
Yes.
ठीक है. ठीक. Okay, thank you. 13, 0, 5, 5, 7, 1,
22 5. 5.
Completed?
Yes, sir.
और तो कुछ नहीं था ना? Nothing more was there?
Yes,
No,
sir.
sir.
Completed, sir.
Today that two questions I have given, I'll discuss in next class. After I will discuss, I'll start from first. I will start from synchronization, critical section. Race condition, critical section, logs, test set logs, priority inversion. उसके बाद वो क्वेश्चन को सॉल्व करूंगा. ठीक है? So our first topic is completed. CPU scheduling. I have discussed all the possible problems. Next class, we will start off with race condition. That is process synchronization.
Okay, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Bye, sir.
Thank you, sir.
Thank you. Bye.
Thank you, sir.